Hi everyone, I'm Grace Lee, a scientist here at Countable Labs, and today I'm very excited to walk you through a recent case study that I did that really highlights how Countable PCR's broad dynamic range makes it very easy to confidently measure the presence of rare molecules in your samples. So this case study specifically focuses on JAK2, which is a well-known cancer target, and I prepared known ratios of wild type and the JAK2 V617F mutant. In the setup, the wild-type JAK2 is present at relatively high amounts, while the V617F mutant is present at very low abundance. That ends up making it really challenging to detect the mutant with statistical confidence. And a common workaround that's used in the field of rare molecule detection is using a pre-amplification protocol to boost both the rare and the wild-type molecules. So now I'll quickly walk you through how I designed this experiment. I started by preparing a sample with an expected variant allele frequency of 0.033%. This just basically means that for every 30,000 wild-type molecules, I'd expect to detect one mutant molecule. Without any preamplification step, I used Countable PCR and was able to detect, on average, 4 mutant molecules in about every 23,000 wild-type molecules. But obviously, because 4 is such a small number, any variation between replicates ends up introducing a lot of error. And that's why the CV across replicates is 90%. And also, the limit of blink was nearly the same as the sample here. So clearly, this isn't reliable enough for confident detection. And that's where the preamplification step comes in. It's a very quick 12-cycle endpoint PCR protocol that only takes 20 minutes. And when I preamplified an aliquot of the sample, both the low abundance JAK2 mutants and the highly abundant wild-type molecules are amplified together. Preamplification preserves the original mutant to wild-type ratio with the added benefit of increasing total molecule count. This boost gives us greater statistical confidence in the measurement, and this is essentially an application of the law of large numbers. And afterwards, I took the preamplified sample, ran our standard Countable PCR protocol using the 2 different sets of probes, one targeting the wild type, the other targeting the V617F mutant. Both probes were included in the reaction, allowing for the simultaneous detection of wild type and mutant in the same tube. So now that we're working with a much higher number of molecules for both the mutant and the wild type in our sample, we also have more confidence in the value reported for the rare mutant counts. And this kind of simultaneous detection of wild type and mutant in the same reaction just wouldn't be possible with digital PCR, purely because the number of wild type molecules we're working with after preamplification is almost at 400,000 counts. And that number just far exceeds what digital PCR can handle because of the statistical limitations of Poisson correction. You'd basically either overload the platform due to such high wild-type counts, or would have to dilute the sample so much that you lose the sensitivity for your rare mutant counts. So you might be asking, what does this all mean? Essentially, the preamplification step let me confidently measure a VAF of around 0.04%, which is very close to the expected 0.033%. Additionally, the CV dropped from 90% before to now 16% after preamplification. The practical advantage here is that Countable PCR has a very wide dynamic range that makes it possible to measure both very rare mutant and very abundant wild-type molecules in the same tube at the same time without any need for multiple dilutions or splitting of the sample into separate experiments. This means that users get statistical confidence in their data without having to burn through any extra material or run additional experiments. And this is especially important when we think about how little material is present in cfDNA or other liquid biopsy samples. So I've worked with some of our early access users who have focused on rare molecule detection, and they've been very impressed with Countable PCR sensitivity. If you would like to learn more about how Countable PCR can help with rare molecule detection, please feel free to contact one of our specialists today.